let's get some practice with volume for these three-dimensional objects. So this first one here, just kind of recognizing the shape of it, this would be our rectangular prism, which we talked about a formula for. There's also just the method of seeing base area times height. But what this should come down to is width times length times height. And with multiplication like that, order doesn't matter. So maybe you see length times width times height. Maybe you see height. It can go in any order and all does the same thing. So width times length, what we're visualizing here is our rectangle that's making up the base of the three-dimensional object here. So we have this 4.6 by 1.9. And then for height, we want to think about repeating that shape, and it's going to repeat up 3.2 feet. So what we'll have here is 4.6 feet times 1.9 feet times 3.2 feet. So for numerical value, just multiply the numbers, and that should be 27.97. And then for units, we'll have feet cubed. So that's the volume of our rectangular prism. Here's one that we haven't looked at in the videos yet, but this would be a prism. So what you'd want to recognize is what shape is repeating over and over. Again, in that first video, it's kind of like, how do you want to cut the cake? If we cut in this long way, like there, we'd have this rectangle, but then if I cut over here, it's a rectangle, but it would be smaller, and we want to see the same shape. So then I could think about cutting in the other direction. Let's say I cut this way. In this way, I would see the same shape over and over without any sort of change to it. So with that, our base shape that we're looking at, and I'll just grab the one that's right up front here, this is the base shape. Now this shape here, we've talked about before, it has a pair of parallel sides and then other sides that are not parallel. This is our trapezoid. So what I'm going to think about for the volume of this one, so this is a trapezoidal prism. And with this one, I'm going to think about that base times height idea. So I'm going to think about the trapezoid area. And then I'll think about multiplying that by the height of the prism. Now, height of the prism, I've outlined my kind of base shape here. So the height of the prism would be how many times that repeats, which will be going in that direction there. So height is going to be 23. So I already have that. But what I need is the calculation for the trapezoid area. So trapezoid area is just a reminder of our formula. So that's going to be a half times, and this is going to be a little tricky because we're talking about height and base and height, and this is a little different. Like this will only be for our trapezoid piece, but it will be height times base 1 plus base 2. Now for this, and I'll even redraw our shape here where we have 14.2 centimeters, 19.8 centimeters, and we also have this 13.5 centimeters. So in terms of labels to how it would match up with our formula, bases make up the parallel side, so we just need to call one base 1 and the other base 2. And then for height, that's where we have our perpendicular. So the perpendicular between those two sides, which would be that 14.2. So for trapezoid area up here, I'm going to be taking 0.5 times the height of the trapezoid, which is 14.2, times, and then in parentheses, adding those bases together, 13.5 plus 19.8. So what you can do is put into the calculator this trapezoid area times 23. You can plug that in all at once, or you could separate it up, but you should get out a 5,437.89, and then our units are centimeters, and those units would be cubed. So that's where you might need to do a little side work, get that area, and then calculate. I've seen this done other ways too. Maybe you think about separating it up. You could separate it into two separate volumes where you have a rectangular prism and then you're adding a triangular prism, and you'd get the same thing out. But let's move on to our next one. So this one right here, we can think about our base shape is going to be the triangle. That's a shape that's kind of repeating, and then the height runs along this side here. So we're going to take the triangle area times the height of the prism, which that height there is 45. So what we need to figure out is what's the area of this triangle. So with this triangle, and I'm going to do kind of the same thing as up above. So we want half base times height of our triangle. And what we have is we actually have an equilateral triangle here. So we have 28, 28, which would actually make that other side 28 as well. So in terms of base, that would be 20. 28 is our only option there. So for our formula, we'll have 1/2 times base of 28 times height, which we need to do a little bit of work to get that 90-degree angle there. So let's see. With this, we have a hypotenuse of 28. With this base of 28, we've cut it in half. So we really have this 14 down here. And then what we don't know is the height. So for height, we need to solve, but we have a Pythagorean theorem here. So what we're going to do is our hypotenuse squared equals leg of 14 squared plus unknown leg squared. And then we'll just start solving. So h squared would come from 28 squared minus 14 squared. And we just need the square root of that, which should be 24.25. What are units? Meters. So with that for height, what we're going to do is plug in 24.25. So that string of multiplication there will give us our overall volume, which should come out to be 15,277.5. Sorry, that's a comma there. Meters cubed for volume. So those are some examples of prisms, both that we have formulas for and don't have formulas for, but we can adjust based on the previous formulas for area. All right, our last one here is a composite figure. We're mixing two shapes. So we want to end up adding two volumes together. So at the bottom of the shape, we have this rectangular prism. So I'm going to want the volume of that shape there. And then once I have that rectangular prism, I want to add on the pyramid. So we're going to add the volume of the pyramid. So rectangular prism, what we need is length times width times height. So looking at our rectangle here, we have 14 by 10 by 4. So we're going to multiply those values together. And that would give us our rectangular prism. And then what we'll do is for the pyramid, what we're going to need for our formula, we just go plus, is it's the same formula, the length times width times height, except we're taking a third of it. So we're going to have different length, width, and height based on our shape here. So we have 6. And sometimes with pyramids, they have square bumps, and there should be more notation, maybe something to say those are the same side. Since they left off the other side, I'm going to go ahead and assume that's 6 as well. And then this 10 here is giving us the height. So we're going to have 6 times 6 for that square pyramid and a height of 10, and then divide by 3. And then we're just going to combine all those values together, which should be 680. And then for units, they didn't actually give us any units here, so let's just write units cubed. So that's how we can combine multiple volumes together for an overall shape. So that's some practice there, and kind of mixes our formulas together as well as the idea of just prisms.